Hi, I'm Daniel and I'm the creator of the Raspberry Pi Nintendo console. For those who don't know, the Raspberry Pi Nintendo is a console which I designed and printed in 3D, and it plays all the cool games back from the 70s till the late 90s on your big ass television with the HDMI cable. In this video I'm going to show you how to build your own Nintendo in really easy to follow steps with high detailed images and video. If you don't like soldering or you're not into electronics or software or programming, don't worry, you can get a pre-assembled and pre-configured Nintendo at iprototype.com, or you can buy one from me directly if you send me an email or a personal message, and I will ship it to you wherever you are in the world. The project is a little advanced, so to make things easy, we're going to divide the project in 3 easy to follow parts: the electronics, the software and the programming, and last, the case, the 3D printing and the mechanics, the automated cover. Let's get started. Okay, we're going to start with assembling the electronics. For each project it's probably best to use a schematic. I've drawn one in the computer, so let's take a look at what we are actually going to build. Looks a bit difficult, but it's really easy and it just contains a few important parts. Here we see the big components. Here we have the USB hub. Here we have the 4 indicator LEDs. This is the ATX Raspberry board, 2 LED switches, the Raspberry Pi computer itself, the stepper motor driver board with the stepper motor. This is the power LED or the indicator LED. And this is the male DC barrel adapter, I think it's called. And this is the way we're going to attach everything together. So we will put 5V directly through a 680 ohm resistor to the power LED. There's also 5V going directly to the USB hub and 5V directly going to the ATX Raspberry board. The Raspberry board makes it really easy to turn your Nintendo on and off, and also to reset the Nintendo. And this is done by a switch, and we can mount the switch or attach the switch directly on the board with just 4 wires. And first a 5V and a ground wire. This is for the LED, of course. There's no resistor needed. And a signal and a ground wire. And we're going to connect the signal wire to the normally open connector, which is really important. So normally open, not normally closed. This is for LED 2. We are using the normally open connector. Okay, then there are some cables coming out of the Raspberry or the ATX Raspberry board, and I will explain them to you. Most of the wires that are coming out are power wires. So there's 5V and ground going to the Raspberry Pi computer, and there is 5V and ground going to the stepper motor driver board. The blue and the yellow wire is for communication between the Raspberry Pi and the ATX Raspberry board. Here we have the LED switch number 2. This is for opening and closing the cover. And this switch is a little bit different because we will solder the signal wire to the normally closed connector, and we will use a small capacitor in between. And this is for the debounce function. I will explain this later, but it basically means that if you press the button, you want the lid to open and not to close automatically, or open 2 times. You want it to happen only 1 time. And the software debouncing function is not working perfectly, so the capacitor will solve all our problems. There are 4 pins from the Raspberry Pi computer going to the stepper motor driver board, and there are 4 pins going to the LEDs. Pin number 9, 10, 27 and 17 are going to the stepper motor driver, and pin 11, 13, 19 and 26 are going to the LEDs. You need to be really careful because we need to solder a resistor, a 680 ohm resistor, to each of the LEDs. And we will solder all the ground pins together. They're going to one of the ground pins, one of the ground GPIO pins on the Raspberry Pi computer. The USB hub is getting 5 volt directly from the DC female barrel jack adapter. And there is a USB micro cable, oh no, it's not a micro, it's a USB mini cable going to the Raspberry Pi. And we need to be really careful that it's not backfeeding the Pi. The Raspberry Pi computer will get power from the ATX Raspberry board. This is the only power source we want. We do not want to power it too much, so we need to make sure that this USB cable is only transmitting and sending signals and not, well, pushing any current or power through. Here is a GPIO header layout. I marked all the pins we will use, but I didn't mark the ground pin. You can choose which ground is close for you or convenient for you. But these are the pins, the colored pins are the pins we're going to use. So, now that we know what we're going to do, we're going to prepare the electronics. We're going to prepare the ATX Raspberry board by soldering some headers on it. We're going to take the push buttons and solder some wires on it as well. We're going to open up the USB hub, and we are making the LED strip with the resistors so we can mount everything together correctly. Let's begin. Okay, let's start with the ATX Raspberry board. It comes pretty complete already, and all we need to do is solder some male headers on it. The headers are included. Let's cut them to the right length. And to fix the headers in place, I'm going to use some putty instead of tape, and this works really well. So the ATX Raspberry board is finished, and now these are the momentary switches, the blue one and the white one. And here we have the positive pin and a negative pin for the LEDs. And there are 3 pins for the button. This is the common pin, the normally open and normally closed one. And for the first button, the blue button, we are soldering the wires to the normally open position and ground. Instead of soldering all the wires together, I'm using crimp female connectors. It takes some practice, but this is what a good crimp looks like. Also, don't forget to test your wires both on continuity and resistance. First button is ready with the connectors all nicely protected with shrink wire. Let's do the second one. Second button is also finished, and don't forget to solder the capacitor and the wires to the normally closed position. Okay, let's get started on the USB hub. We need to take it apart, and there are 4 screws, 2 on each side. We unscrew them to remove the back plate and the front plate and get the board out, get everything apart. Let's go. Before we continue, it's very important that we know how to solder some power wires on the board directly without using the rather large DC plug. So first we plug in the original adapter, like this. LED is active. And now we test the soldering points for the current direction with our multimeter. Let's get the wires. Positive and ground, hopefully. Yep, 5 volt. Double check. For extra safety, we're going to hot glue the wires directly on the board. Yep, like this. Okay, now we need to make the power connector. And this is a little bit of work because it connects to the ATX board, the USB hub and the indicator LED. So let's start stripping, crimping and soldering wires. Don't forget the shrinking tube and the 680 ohm resistor. Now that the buttons, the USB hub and the power connector are done, it's time for wiring the 4 LEDs together. Here are the 4 bright LEDs. And these are the 4 680 ohm resistors we need. And for the ease of use, we are going to use the 3D printed top part of our case as a mold for easy soldering. So let's get everything out of the way. And insert the LEDs one by one in the 5mm holes. And we do this with the positive pin up. And the positive pin is the long pin. Okay, and now we're going to bend all the short wires, these are the negative wires, together to the left, like this, so that they're touching each other, and be very careful that no ground pins touch the positive ones. Like this. Okay, let's solder. Okay, connect the bench power supply to the LEDs, 5 volt, to test them, and then we're going to solder the wires on them. So everything is finished. The USB hub is done. Power supply, stepper motor, ATX board, the LEDs and the 2 buttons. And now that we're done preparing the electronics, we can finally unwrap the Raspberry Pi 2 Model B and then assemble and test our rig. And we are just going to connect the parts together with pre-crimped jumper wire following the schematic. So, exciting moment. Let's plug the power supply in. So, the power LED is turning on. The USB hub is turned on. This is the LED. And now it's time to press the power button. It's lighting up. Everything is working. The ATX Raspberry is lighting up. Raspberry Pi. Now the stepper motor will turn. Yeah, it's turning. Now the LEDs will blink. Well, perfect. They are working, yes. Good news. Oh, we can test the white button. So the stepper motor needs to turn and the LEDs will go off. Yeah, it's working. LED is turning on. Yeah, perfect. Let's check if the shutdown script is working. Hold the power button for a few seconds. It's blinking. So now it's shutting down the Raspberry Pi. And if everything is alright, it will blink faster. Yeah, it's working. And it will turn off by itself. Perfect! So, in the next part we're going to build this rig in our custom case, install the software and get the automatic opening cover working. See ya!